Hello everyone. So in this pre-lecture tutorial we're going to discuss how it is that we can determine the empirical formula of a compound. However, if we're going to determine such a formula, then we should have some idea of what an empirical formula is. And essentially what the empirical formula of a compound is the formula that relates the simplest whole number ratio of elements within a compound. So for example, I've listed a few compounds here on the slide. And so if we take a look, here is the formula for carbon dioxide. Now, essentially, that means I have one carbon atom for every 2 oxygen atoms in carbon dioxide. Now notice that this ratio, 1 to 2, is already the simplest whole number ratio. In other words, there are no common multiples, or any common factors, I should say, between 1 and 2. So similarly, here I have sulfur hexafluoride. And again, there is 1 sulfur, and there are 6 fluorines. And again, between 1 and 6, there are no common factors. And so, as a result, then we would consider this formula, SF6, for sulfur hexafluoride to be the empirical formula, because it relates the simplest whole number ratio of elements between sulfur and fluorine and sulfur hexafluoride. Similarly for calcium fluoride, basically there's 1 calcium and there are 2 fluorines. And as in the case for carbon dioxide, there's a 1 to 2 ratio. And so again, that is the simplest whole number ratio that can exist between calcium and fluorine, because there are no common factors between 1 and 2. However, if I take a look at the formula for glucose, for example, here I have 6 carbons, 12 hydrogens, and 6 oxygens. And so basically between these 3 elements there is a common factor of 6. Which means I can divide through each of these subscripts by 6 and come up with a formula that gives me a simpler whole number ratio of elements. Basically, that would be this formula CH2O, where there would be 1 carbon and 2 hydrogens and 1 oxygen for this compound. And so since the simplest whole number ratio is communicated by this formula, then we would consider CH2O to be the empirical formula for glucose. Now that we understand how the empirical formula works, let's try and figure out how we would actually determine one if we needed to. And as it turns out, if you recall, it comes down to understanding what the subscripts in a chemical formula actually tell us about the compound. And if you recall, basically the subscripts in a formula give the mole ratio of elements within the compound. And so what that means is, if I can take the given information and actually convert each amount of element that I'm given to moles of each element, and then take the ratio over those molar amounts, then I should be able to find the empirical formula. So, for example, I'm told that I have a compound, and this compound has 79.8 grams of carbon and 20.2 grams of hydrogen. They want me to determine the empirical formula. And so once again, I want to determine the ratio of moles of each of the elements in the compound. And so what I can do is, I can go and start with this 79.8 grams of carbon, and let's convert that using the molar mass of carbon to moles of carbon. So if I do that, I would take 79.8 and divide that by 12.01. and I get 6.64 moles of carbon if I do that conversion. Now, let me do the same for hydrogen. So basically, I would take the 20.2 grams of hydrogen, and I would divide that out by the molar mass of hydrogen, which would be 1.008 grams of hydrogen for every 1 mole of hydrogen. And so, if I do that division, I end up with 20.0 moles of hydrogen. And so from here, in order to get the simplest whole number ratio between these two molar amounts of carbon and hydrogen, I'm going to take my smallest result, so that would be this 6.64 moles of carbon. I'm going to divide that out by 6.64, and I'm going to get 1. I'm going to do the same for the hydrogen. So then that would be 20 divided by 6.64. And I get 3. So that means that the empirical formula for this compound should have these subscripts next to their respective elements. So that would be C, 1 understood, H, 3. So that's the empirical formula of this compound. Okay? Now, sometimes we're not quite so lucky in the sense that we're not given straight up masses of each of the elements. A lot of times we're given problems where we're actually given the percent composition instead. Now, that isn't as big as a complication as you might think. So let's actually take this problem apart. I'm being told that I have 52.14% carbon and 13.12% hydrogen and 34.73% oxygen in this compound, and they want me to calculate the empirical formula. And so for these types of problems, the very first thing we'll do is we'll assume that we have 100 grams of sample. And what that does is it allows us to take these numbers and directly convert them to grams without having to do any math, because essentially having 52.14% of 100 would mean that I have 52.14 grams of carbon. And I'm going to have 13.12 grams of hydrogen. And I'm going to have 34.73 grams of oxygen. And so I'm going to go ahead and do what I did in this first example that I showed you at the top of the slide. I'm going to convert to moles using the molar mass of each of the elements. And so starting with the 52.14 grams of carbon, I'm going to use the molar mass of carbon. So that would mean I would take 52.14 grams of carbon divided by 12.01 grams per mole of carbon, and that gives me 4.34 moles of carbon. Now I'm going to move on and do the same with hydrogen. So I'm going to apply hydrogen's molar mass. Okay, so that would mean I take 13.12 grams of hydrogen, divide by 1.008, and I get 13.0 moles of hydrogen. And then I'm going to do the same for oxygen. So the molar mass of oxygen should be 16.00 grams of oxygen for every 1 mole of oxygen. And if I go ahead and do that math, that'd be 34.73 divided by 16, and I get 2.17 moles of oxygen. And so once again, once I'm at this stage, I'm going to take my smallest result, the 2.17 moles of oxygen, and I'm going to divide each of my numbers of moles for each of the elements by that smallest number of moles. So that would mean I have 4.34 divided by 2.17. That factor ends up being 2. I'm going to take 13 divided by 2.17, and that gives me 6. If I go ahead and take 2.17 and divide by 2.17, then I get 1. So that means these factors are the subscripts in the empirical formula. So and that means the empirical formula for this compound would be C2H6O. Okay, so there are more complex problems than this. We'll cover those more complex problems in class, just because I think it'll be something that we'll need to talk through. But for now, work on the follow-up assignment. See if you can apply what we've discussed in the pre-lecture tutorial. Again, if there are any questions, by all means, email me, or if not, we'll definitely speak in class. Have a good night, and I'll see you in bed.